subject in the module 3B, study of automatic generation controller in interconnected power systems. After having studied the typical role, operation, numerical computations concerned to AGC, in fact it is an ALFC, and understanding its relevancy, and we are now moving to interconnected operation, how AGC is going to operate or going to control the operations of the power system, like that. Let us move with the next slide. What is the meaning of interconnected operation? What do you mean by coherent operation of a system? What is the control area, like that? We all very clearly know a area, a geographical periphery, a part of the power system, till that geographical view or purview, the common control signal reach and control that particular geographical periphery with all interconnected communications and exchange of information, till that signal from the common controlling point reach and act. That periphery we call as a control area. In that control area, let us say a plant with a generator is situated. It is supposed to generate adequate megawatt and pump to the grid. When we say the word coherent, the generators are said to be in coherent operation if they are swinging with a single frequency. They are operating at the common frequency and their characteristics are very similar to which. Swinging with the common frequency, we call it as a coherent. And we can replace all those generator. Suppose there were 10 generator in the system, as an equivalent one generator to represent mathematically. That is the role. When we say the word coherent, I can replace all the 10 generator into one R by equivalent plus D. 1 by R equivalent stand as the group response of all 10 generator in that locality as a single equivalent generator 1 by R equivalent. That is the role of, that is the way we can represent coherent systems. So when I have a system, a coherent system, and another system, and another A, B, C, like that, naturally interconnected operation become very necessary for the corporations to exchange the power whatever they generate. Trading of power, when we consider, it become very necessary. For the profit of corporation, sometimes it is not advisable to set up a generator and deliver. Sometimes it becomes very profitable if they borrow the power from the neighbor corporation and meet the requirement of the loads at the local. In that due respect, interconnected operation become inevitable. Then we have some parameters to be understood how exactly power flow occur among the control areas. Then what are all the things that the control areas need to adhere and view? The first parameter, when we have a different control areas are interconnected to one another, definitely automatic generation controller installed in area 1, area 2, area 3 are with certain objectives. Like they have to look for their own generation and demand in their area effectively, making the resources optimally utilized, meeting the end users desired specification, and they should see to it that they are able to meet the requirement of the neighbor corporation if they have accepted an agreement of delivery of power or borrowing of power. We call it as trading. In that perspective, the corporations which are interconnected themselves, they need to install the tie lines. Tie lines are the transmission infrastructure between the energy corporations like A, B, C, etc. Basically, they are meant for the exchange of power, which the excess power, if the corporation is possessing, it can trade to the neighbor. If it find a deficit of generation due to any reason, maybe generators on maintenance, due to some sudden fault, a certain generator areas are disconnected, you would like to meet your requirement and you can borrow the power. These infrastructures would help at the time. Then they should have tie lines among them, and AGCs of each areas A, B, C, D like that should have now special feature and special role in the interconnected operation. That is the one, hold the system frequency close to the nominal value whichever is specified. For us, if I say 50 hertz, all the interconnected areas should have the AGCs or AGC in those areas should have objective to maintain the frequency very close to the steady state defined like 50, and they should maintain correct value of power interchange between control areas. For this, you just recall control area control error, a concept we have defined. What was that area control error? Area control error is a value, error value of a control area, which says the generation in that area is adequate and able to meet the requirement of the commitment that that area has done. Like ace of an area is said to be plus by value. What it would indicate? The area is having a sufficient generation and meeting the requirement effectively which it is committed. Then if it is said to be negative, ace is said to be negative, area control error of a locality or a area A or B or C like that is negative. What it would mean? It is deficit in generation. Find shortfall of generation. It is to necessitate the interconnected operation or borrowing up of power, or other way, demand side strategies, removal of load, disconnection, managing the load in an effective manner, in a time staggered manner should be done. For that, AGCs, when they are interconnected into operation, they should maintain the correct value of the interchange between the areas. Maintain generation of each unit at most economic value. See, this is very important aspect. When we have a generator with a certain fuel, the raw material, whatever is the hydro, thermal, oil, coal, or gas fired, or natural, or even nuclear, the resource play a very important role here. The irreversible nature of the fuel makes it so interesting. Whatever the fuel we utilize to generate the power should be seen very cost effectively, because when you burn the fuel for the purpose, the calorific value of which will not be there at the end of its usage. The reusability I'm trying to cope up. Therefore, you should see to that most economically you should schedule the generator, the cost effective units which are optimal in producing megawatt for a requirement, and the usage of fuel is so optimal they reserve fuel for the future use also. In that way, these are the three things we should be kept in the mind of a AGC in an interconnected operation. Then, how is that the last parameter is important? You may have a question. In an area, there is an hydro generation. In an another area, think that there is a thermal. In an another area, there is a nuclear-based power plant. How do this most economic value of generation matter? Definitely, when interconnected mode of operation is expected, exchange of power among the corporation is definite. Definitely due to variation in the load, due to corporation is due to sudden increase in demand or due to a massive fault over there, there is an absorption of used power. And how is that? Second point, to maintain correct value of power exchange between the control area is attained, they must start accelerating their productions due to fault or due to absorption, whatever. So from the interconnected area, the committed generating area need to produce higher and higher megawatt on demand to balance their area control error zero. Therefore, there may not be a cost effective operation in some situations. In that due respect, when they are committed to meet the requirement of end user among their corporations, they must see to it that that is not the only commitment. The commitment is to see to it that meeting up of requirement as well as the maintenance of the resources for the future has to be seen in a very scientific manner. That's how it should be provided. Okay. Now, let us see how is that interconnected mode of operation is basically considered for the initial start of the study? Let us see the diagram. There are two control areas where area 1 and area 2 are interconnected by a tie line. Area 1 and area 2 are interconnected by a tie line with the transmission reactance X type like that. Let us expect there is an exchange of power from area 1 to area 2, like power flow from area 1 to 2 is P12. What is that megawatt transferred from 1 to 2? That is given by the expression written at the right. The bus voltage of the transmission section bus at area 1, say E1, and angle delta 1. E1 delta 1 is the parameter concerned to bus 1 at the area 1. Similarly, it is connected to area 2. Let us say there is another bus which is interfaced with the tie line. E2 delta 2 be the value of that. Then transmission line reactance total between them, like X12, if I call total reactance of the path starting from the generator X12, which is X1 from its reactance, X tie line, whatever the reactance, and X2 of the generating area 2. When I interconnect, that becomes total representation. Power transport in the power system from one bus to another bus in the interconnected operation is E1 into E2, the magnitude, divided by the path reactance, and sine of the angle between the buses delta 1 and delta 2. Nothing but vector E1, vector E2, the bus voltages, whose angles are delta 1, delta 2. So on which sine of the angular difference between the bus 1 and bus 2 is to be done. Now you might look forward. The arrow mentioned is P12. 1 to 2, there is a flow of power. When I have an interconnected mode of operation of power system, definitely power flow occur bidirectional, 1 to 2, 2 to 1. In that, typically, as and when there is a need of flow of power from one to another. This example show you P12 means there is a specific flow from 1 to 2 only, which is given by the rising edge of the angle delta 1. If delta 1 is leading with respect to delta 2, therefore we say power flow occur from area 1 to area 2. That's the reason arrow is mentioned from area 1 towards area 2. It is mentioned as P12. P12 is read as power flow from bus 1 to 2 is the magnitude of the voltage of the bus 1 into magnitude of the voltage bus 2 divided by the path reactance from end to end and sine of the angular difference between the vector E1 and E2, that is delta 1 and delta 2. Then this is how power flow occurs. Then you may ask me, is P21 is equal to minus P12? Absolutely correct. P21, if I want to compare here, is P12. You can just see here. P12 is by this way. What is P21? Exactly opposite to this, nothing but delta 2 minus delta 1. At that time, I will be writing. No doubt it is E2 minus E2 into E1 divided by X21. X21 is the same as X12. Sine of delta 2 minus delta 1. At that time, delta 2 must be rising compared to other one. So that time P12 is minus P21. So this is how two areas very basically considered as. Let us move at tie line control. Exchange of power between these two corporations via the tie line only with the primary speed control. This is very interesting. What we are trying to study here is automatic load frequency controller circuit, which is having two control paths. One is primary control, which is just taking care of the speed of the turbine and compensating the valve positions to make out the mechanical supplement to the drop in frequency. That's all. Turbine speed must be maintained to a certain RPM, which definitely quantify a megawatt what should supplement to the grid. So any variation in that delivery is definitely causing a change in RPM. The drop in RPM is simply compensated by the governor through the primary control loop of the ALFC to open close like a modulation at the wall being done, so that mechanical supplement is worked out to the turbine. Turbine should make the generator to generate additional power as required. That is how today we will begin with the first heading, tri-line power. How is that exchange of power among the corporation via the tri-line using only primary speed control occur? It will not check the line frequency. It will just see to it that as and when there is a loading phenomena by the area 2, when borrowing the power from area 1, definitely P12 become a load on the area 1. As the load on the 1 increases, naturally turbine decelerate. When the turbine decelerate, how is that turbine is going to cope up for the megawatt exchange appropriate, like your point number 2 in the objective? Therefore, the primary loop comes into picture. The primary loop start making the valve opening in proportion to that. Therefore, mechanical supplement is done to the turbine to see to it that P12 is addressed. That is how primary loop comes into picture. We will initiate. Let's see the similar scenario. This particular expression which I have mentioned in the previous example, this one, P12 delta 1 E1 E2 over X12 sine of delta 1 minus delta 2 with this path is linearized. So it is linearized and it is written, let us say initial operating point of delta 1 be delta 1 initial 0, delta 1 0 says delta 1. The angle associated with the vector E1 or bus 1 delta 1 at initial point 0 2, similarly delta 2 as delta 2 0. We can rewrite it as initial condition delta P12, infinitesimally small exchange of power from 1 to 2. A small change in power delivery from 1 to 2 can be written as delta P12 as, you can see here, delta P12 as E1 E2 over X12 cosine delta 10 minus delta 20 at small angular change delta 1. As well, when it is a highly inductive system, when you have sinusoidal function here, you can see sine. When it is a highly inductive system, Jx becomes 90. So this J, an angle of 90, make this sinusoid into cosine. That's what is going to happen. So E1 E2 divided by X12 cosine initial operating angles of the vector E1 with the delta 10 and delta 20 of the other. Then we can write what is this minute change in angular deviation or minute change delta 12. Delta 12 is a minor change in angle delta 1 minus delta 2. A small change in angular values of vector E1 E2 is rewritten as delta 1. It is natural. When a minor shift in demand is noticed, it will affect in a minor value only. Hence, we are trying to say for an infinitesimally small change in delivery of power from the bus 1 to 2 is quantified as E1 E2 over X12 cosine delta initially operating from bus 1 point of view minus delta operating point of the delta 2 to 0 and infinitesimally small angle delta 2 1 2. Then this term is such a written, the E1 E2 and X12 is written as T. Let a term given as E1 E2 divided by X12 cosine delta 10 minus delta 20 is written as, let us write this initial term E1 E2 divided by X12 as some peak power. When this value of cos of delta 10 minus delta 20 turns to be 1, let's say this is the only value E1 E2 divided by X12 that we are calling as P max. The term E1 E2 over X12 is P max when cosine of this total value goes 1. Then we have invariably this total term is defined as T equal to P max cosine delta initial operating value of an angle of that particular bus 1 voltage and initial value of the bus 2. Then we know delta P12 infinitesimally small exchange of power among the corporation is written as delta P12 equal to the term, this term which is T. T refers to whole term into delta 1 2 angular minute change. Now you can see. So again I rewritten the diagram of initial condition in initial interconnection. Area 1 is connected to area 2. The total path reactance X12 is split as from the generator or area 1's perspective of generation E1 with the delta 1 whose reactance X1. Generators equivalent reactance mentioned as E1 delta 1 X1, E2 delta 2 X2 from the generator perspective area 2 or area 2's representation, area 1 representation, and between these two we have a tie line. X tie refers to path reactance of the transmission section. Then this is an equivalent single line diagram representation of this particular line. Then we got to know that infinitesimally small exchange of power from plus 1 to plus 2 can be written as the total value P max cos delta 10 minus delta 20 into a change in delta 12, which is a minute change in angle of 1, angle of 2 interconnected. Once it is interconnected, how I can draw this concept using block diagrams, because it becomes necessary once I have an interconnection diagram, once I have its single line diagram, how a control system block diagrams can be represented to see to it that such an infinitesimally small exchange of power is addressed among the corporations which are committed to exchange the power. It is like this way. Yes. When I have two areas, let's see. Now I have one interconnection. Now we will consider very simple. Let us view only the first upper half view. What it exactly represent? Are we able to recall something we learned in the module number 3A? Yes. This represent to an isolated area initially. Only I am speaking about the upper half, which is a governor's representation by a first order lag function, turbine representation by a first order lag function. Then directly I go with the area and response of the frequency sensitive load, frequency insensitive load representation, and deviation of the frequency whatever would occur in that area, which is being fed back through the droop of that governor back to the input correction to the governor, wherein I have P reference set point from the speed changer reference set point, and the actual power fed with the deviation and the droop, which is compensated with the summer block and fed as request for the governor to change the position. I mean to say this upper half of the representation is exactly primary ALFC controller. Primary means what? Only the speed feedback is taken to the control using the droop nature. We are not considering the reference point shipment. Reference point is fixed. Reference point and the command what is coming over here is from the speed changer. Speed changer value and the power computed from the deviation is used via the droop to see to it that there is a change in request to the governor. Governor will transform this frequency deviation error to displacement of the wall to be opened or closed. That is nothing but output of the governor block. Then governor block delta PV of 1, certain 1 say, will make the turbine to accelerate. If there is a deviation lagging, it need a shift of frequency, means frequency drop is noticed. Then what is to be done? Valve need to be opened so that higher fuel inrush to the turbine area and turbine start developing more and more mechanical power. It means to say, if there is a drop in frequency in an area, this is fed back via the droop characteristics of a governor mechanism to the reference set point, and these two together simulate an error. That error is nothing but a stimulus to the governor. Governor will reflect that change required into a displacement of the valves. Valves opening, mechanical displacement, nothing but the displacement of the valve, nothing but higher fuel or lower fuel, depending upon the value, is caused on the turbine. According to the displacement, turbine will change its mechanical output. This mechanical output, which is connected to the shaft of the generator again makes the generation adequate to the change in mechanical power, such that there was a need that electrical load was increased. Why do frequency deviation occur? Maybe there was a load insensitive to the frequency, infinitesimally small, or there was a sensitive load over there with a D. What really has caused has to be addressed by the area and this control. So that has been seen in the primary part of the ALFC in a single area. This is what? Single area. Now that single area controller is just taken into two parts. Now you can see similar writing, similar representation is there in the lower half of the representation. That is the title called as two area system with primary control. Hope I have made the clarity to you how primary loop in a area, single area, is represented by interconnecting similar control loop in the area 2, like same mechanism. Turbine in governor turbine area representation of 1 is just taken as a similar, the governor in second area, turbine in second area, then areas reflection, areas representation, and areas frequency deviation. Like this area 1 is having 1, 1, 1 as a subscripts. You can see there. Reference point setting of 1. Governor's displacement as 1. Mechanical supplement to the turbine and developed mechanical power delta PM1 drew by 1, and load insensitive to the frequency PL1, and area reflection by damping constant 1, and inertia by H1, all, and frequency deviation omega 1. All these refers to area 1 perspective. Similarly, I have second area its own. If I view isolated control, I have reference point setting in that area 2, and I have a governor in that area which give the valve displacement PV2, then turbine in that area with the PV2 displacements, mechanical changes. Then this mechanical change according to the loads in that area delta PL2, you can see here infinitesimally small request of load change would definitely reflect difference as delta omega 2, and area's response, which is load damping constant D2 and inertia H2, all were very identical, like area 1 how it is redrawn on the paper. Similarly, I have area 2 and its frequency deviation is fed back via the droop 1 by R2, and again I have reference point of area 2, actual computed power from the shaft delta omega 2s divided by R2, take the compensation by error. Error is a stimulus for the governor in area 2. This error is a displacement cause a mechanical substitute to the turbine, which nothing but the acceleration or change in electrical output. So therefore, such two areas are to be interconnected. Now what is our role? Two area system with the primary control only operating for the exchange of power. Now definitely when I have a certain representation over here, area 1, area 2, what is inside area 1? Inside this area 1 we have generator, we have transmission mechanism, we have loads, etc. And all the governor, turbine, everything is just taken inside this area, but they are connected by transmission mechanism called tie line. What is that power exchanged among them is a infinitesimally small power exchanged. Delta P12 is a T representation of the coefficients over here, E1, E2 over X12 cosine delta 10 minus delta 20 into delta 1 minus delta 2. So this is the exchange between these two. Then I should write between the leads over here and leads over here. What is the flow of power? This expression. What is that? Delta P12. How it is flowing? It is flowing from bus 1 to 2 because delta 1 is at rising edge compared to the delta 2. Therefore, when I draw a primary loop of area 1, primary loop of area 2 with a subscript 1 and 2 like that, I have to join them. When I join them, this is the exchange of power among them. The frequency deviation of this area is say delta omega 1. Frequency deviation of this area is omega 2. When they got connected 1 to 1, they work with the unique frequency. Omega 1 is same as omega 2. That's called as one frequency. When they got interconnected, area 2 become part of the area 1 or area 1 become part of the area 2. Both experience same frequency, and whatever the disturbances which are occurring in area 2 naturally protrude to area 1, or whatever the reflections which are to be taken in area will be addressed for the area requirement. Like that, these two get connected to each other, means delta omega 1 and delta omega 2 become one and the same. How is that? Change in area 2 load is addressed by area 2 or area 1, or change in load addressed by area 1 itself, or how it is controlled by area 2. Because when they are having common frequency, naturally power flow become bidirectional. It all depends on the edge of the angle. If the vector E1 with the angle delta 1 is leading with respect to E2 with the delta 2, definitely power flow occur 1 to 2. If delta 2 is leading with respect to delta 1, then power flow occur from 2 towards 1. This is interconnected because I do not have control at that time. It is interfaces that as and when there is a rising and falling edges of the angle, the bidirectional flow initiate automatically. In that regard, what is that exchange among these two areas interconnected? We have a keyword delta P12, infinitesimally small change in power among the area 1, area 2. Let us say from 1 to 2, what is flowing? Delta P12 given as T into delta delta 1 minus delta delta 2. I should write this in the block diagram. That is my requirement. I come back to this. I will come back to you. Delta P reference of S in a frequency domain, the primary set point of area 1, governor of area 1 on the error, whatever the delta omega 1, the frequency deviation noticed in area 1 via the droop nature, which is coming to the summer block. Error of these two is fed as stimulus for the governor. Governor makes the displacement. Displacement on the act of the valves open the mechanical input, then mechanical supplement is noticed. This mechanical supplement and electrical sensitive and insensitive loads, sensitive loads make the response from the area deviation to go 0. This is what the regular explanation we do. Now look at this. This delta omega 1, if I integrate delta omega 1 on integration 1 by S, it becomes delta delta 1. This angular variation, radians per second, when I integrate, this becomes the change in angle delta. So I am going to use an integral part of this delta omega 1, and I'll be representing 1 by S. I'll get delta delta 1. Similarly, look from the lower block diagram. Reference point, set point at area 2, and the actual deviation in the area 2 via the droop, a power mismatch, that is a stimulus for the governor, actuate the valve positions, get the mechanical supplement for the insensitive loads of the area 2, delta PL2, and sensitive loads of area 2, and get that reflected as deviation control. So whatever is that, however this balance should occur in area 2, delta omega 2 represent deviation in that area. This delta omega 2, if I integrate, you can see when I integrate this 1 by S control, this is taken back. One is back to the droop and to the input side. Another point is taken as the integration of that to get delta delta 2S from this angular variation, radians per second. So we are getting the angle of that. So delta delta 1 after integrating delta omega 1, delta omega 2 on integration, we get delta delta 2. So I am reaching angle of area 1, angle of area 2, infinitesimally small changes. Whenever there is a infinitesimally small change in loads in area 1, change in loads in area 2, like that. So all are working with what? Delta at the heading of that. That delta explains infinitesimally small change, like that. So these two together, delta delta 1 to a summer block minus delta delta 2 makes delta delta 1 minus delta delta 2 moving forward with the block T as a multiplier. What is this T? T is what I have discussed here. Delta P12, the actual exchange of power among the corporations is, say, delta P12 is delta delta 1 after integration of the angular frequency of that particular area 1, angular frequency of area 2, take the difference of those two in the summer block and multiply with the T, which is P max cos delta 10 minus the initial power exchange. So when I operate, that is a T block here. Delta delta 1 minus delta delta 2 into T. This comes forward. This comes forward, and let's see how it is interconnected. Now the question is, this is the feedback. Let me make this. Delta P12 is the exchange of power among the corporation. Let us make this very clearly understood. This delta P12, what we discussed is the power delivery from area 1 to area 2. Am I right? Yes. If this area 1 is dealing this power to area 2, how do you consider this? This delta P12 is a small change in power demanded by area 2 from area 1. I would speak either way. It is a power to be delivered to area 2 from area 1. Then this delta P12 magnitude becomes additional burden on the area 1. I am revisiting this in another way. Delta P12 is the power flow from area 1 to area 2, infinitesimally small the increment or change in power. This is nothing but absorption from area 2, or this is an input to the area 2 as a supplement. Area 2 is experiencing a power borrowing that is added to the area 2's generation. There were generators. There are number of generators in area 2. They were not generating as required, or there is a deficit generation, because of which area 2 is requesting area 1 to pump the power. That's what you can say. Delta P12 is the pumped power from area 1 towards area 2. Then how I mean from area 2? Area 2 is experiencing delta P12 towards it to add to its generation. It means to say delta P12 is plus to the area 2 and it is minus to the area 1, because area 1 has to generate delta P12 value additional to its actual loads. This is what I should understand what this delta P12 refers to. Delta P12 is the small, infinitesimally small additional power that area 1 has to generate and deliver towards 2. Then this must be an extra load on area 1, and this must be an extra relief to the area 2. Other way, delta P12 is minus to the upper half of the block represented and plus to the lower half of the block represented. That's what I want to quantify here. Let's look into this. This delta P12, whatever I am speaking here, this is delta delta 1 of S minus delta delta 2 of S on multiplication with the T becomes a quantity delta P12 of S. This is, say, this line. This is going to be a minus over here and this is going to be a plus here. Then how do I understand this? This generating area A or a 1 is exchanging power among these two, delivering power to the neighbor corporation, and whatever is delta P12 is extra load on this. You can see here delta PL1 is what? Frequency insensitive loads in area 1, which is put as minus, which means this has to be addressed by the mechanical supplement and generating area. So therefore delta PL1 is a load on this area. Like that, delta P12 is the exchanging power among the area 1 2. Hence that is substituted as minus delta P12 here. The same way, the same delta P12 is coming as extra tie line power flow to area 2. Area 2 is having a deficit generation. Why it is deficit generation? Maybe its loads are increasing or frequency sensitive loads are playing. Whatever is that reason, the power delta P12 is coming additional to this. Therefore, I would say among these corporations, there is a transfer of power delta P12 where minus delta P12 shows on that particular interconnection that is an extra load on that area, and the same and minus delta P12 when it is a plus, that is a supplement of generation to this area from the neighbor. Then generator over here are getting relief of generation. Whether they were able to generate or not, or there were no generator to generate, we don't know. But the extra power flowing from another area to this area is supplementing the total generation value by plus representation. So I conveyed you what is that delta P12, power flow between the area 1 and area 2. After having integration of the delta omega 1 and delta omega 2, we obtain angles. Depending upon these angles, if delta 1 is rising, leading with respect to delta 2, definitely power flow occur from area 1 to area 2, which is given as delta 1 minus delta 2 into T. That value is, if this is leading edge, this is minus. If this is lagging with respect to this, it must be plus. Power flow occur from area 1 to area 2. So this is the understanding of this connectivity in the block diagram. This was not there when we studied our self primary loop in a single area. This line was not at all there. Only the upper half representation. No integration. The downward movement, this was not there. This arrow was not there. Only straight one line, one droop feedback, and we studied the primary loop. Later we took an integration, that is secondary to P-reference. That is called complete closed loop. That is secondary aspect. But in the primary loop control, we had only straightforward line only. We did not have this connectivity among the corporations. Now we come across two area system. This kind of connectivity make us to understand what is that exchange of power among the corporation, which is delta P12 given by a value of E1 E2 divided by X12 cos of delta 10 minus delta 20 into delta 1 minus delta 2. The same thing I am pronouncing here. Whatever the line I said here, this complete line I pronounced. This is the power among these two corporations being exchanged. Only thing is how it is represented. I am trying to convince you that delta P12 is the power to be delivered from area 1 to area 2. It has to flow from 1 to 2. Then that megawatt is nothing but extra burden on this generation. That burden is shown by minus symbol. This is an addition to this, delivered by someone to this. So this area find relief, that is called added to this, that is plus. How mechanical input is added to this? Same way this flow is added to this. These two plus and minus, which is minus, it is plus here, depends on the edge of this, which is leading, which is lagging. This is the nature of interconnection of two areas. Now the next concept is, when I say they are interconnected to one another, they must be with unique frequency omega only. Then the question comes, what is the value of delta omega 1, delta omega 2 at that time? They must try to balance unique frequency. Imagine these two are far away from each other. They are not just beside in position. They are far away from their geographical position. Definitely the frequency over here and frequency over here need to be same for interconnected operation. But due to the time plane, there will be a small lag of this. So that is how the change in this area's load is addressed by it itself and by this. Change in this area's load is addressed by it itself and by neighbor bidirectional control. How is that worked out in primary loop based control? We have to think. After having understood how is that primary loop interfaced in an area to the another area having primary loop only, This is how exchange of power among them takes place. So now if I move forward, how that delta omega 1, delta omega 2 are going to cause the change in load. Suppose there is an increase in load of area 2. Who will respond for this? Whether it is the generator 2 area has to respond or generator 1 has to respond. Or if there is a change in loads of area 1, is it that load of area 1 is addressed by area 1 itself, or area 2 is also going to contribute? This is what we have to study. That is what is the nature called interconnected operation of the system, only with the primary. When I say how they respond, let us see. Hope I am audible to you all. Somebody reply me. Hope I am audible. Somebody reply me.
Yes, sir.
Please. So once I understand the interconnection of primary loop in a area with the primary loop of a second area by block diagram approach, it becomes necessary for us to understand how is that unique single frequency is attained. How is that area 1 respond for the change in area 1 load? How is that area 2 respond for its own change in load? Or how is that these two area will respond if loads change in 1 or 2 or both sides? There are so many case studies possible with the approach. Let us say such a interconnected area diagram I have revisited here. Let's assume change of load in area 1 itself. There is a load change here itself. Delta PL1 is changing, not the delta PL2. This is static. There is no change here. It's a balanced delivery is going on. Area 2 is intact and a good operation is going on. But they are connected internally so that bidirectional flow is possible by interconnected operation. Now the case study is change of load in area 1. Who will respond for this? That's what I want to see. Consider a load change, delta PL1 in area 1. Let's say a small change in load is experienced. When the system has reached steady state, both the areas will have a common frequency and deviations are also same. When they are at the steady state, after a long time of operation in parallel, both the systems were met unique frequency and deviation values are almost identical. That's what, let delta omega be the steady state common frequency deviation. Let delta omega 1 is same as delta omega 2. That is the concept I was speaking. Unique frequency. When they are put in parallel, steady state operation means controller should not act, everything should be intact. Controller should not act, loads must be addressed appropriately. That we call it steady state operation. So therefore, during the steady state operation, deviation, what you read here must be unique. Then it is other way of meaning frequency deviation from delta F1 from area 1 should be same as frequency deviation from F2 on the area 2. So therefore, in frequency deviation or in angular deviation, both are same when we work on PU. That was discussed in the earlier class itself. Therefore, let us understand, when I have interconnected mode of operation, for a case study, load change occur in area 1. How is that change in load is addressed by area 1, area 2 in this perspective? Let's say from the synchronous machine in oscillation, or they are called they are in synchronous operation. For example, area 1 you consider this area. When I have a balance equation here, observe this junction here in this delta PM1 is a mechanical input to this block. Delta P12 is a flow of power from area 1 to area 2, and delta PL1 is a small change in power which is situated here. I consider these two were in interconnection. They were in steady state. Suddenly a load change in area 1 occurred by a value delta PL1. Then at this point, it is delta PM1 minus what it has to deliver, delta PL2 mean P12 minus the new load shifted over here, delta PL1 should be equal to the deviation over here. What is that? delta omega into d. This is the balance equation which we have seen in the single area. So the only new term what you got is delta PL2 mean P12. This is a new term. Mechanical input minus the load on that should be delta omega into D1 or delta F into D1. This is the equation from power balance in this block diagram. In this block diagram, what you find extra is this connectivity, exchange of power from 1 to 2. This is what we have. Delta PM1 minus delta P1 to 2 minus whatever is the shift in load just now consider equal to whose deflection is change in frequency, delta omega D1. The same equation, similar equation you observe at this second block here. Here, like this mechanical input, delta PM2, and we have input from this side. Can you see here? From this side, it is delta P12 getting added to this. Can you see here? Delta PM2 plus delta P12 equal to delta omega D2. Now, where this delta PL2 has gone? Delta PL2 is not there. Delta PL2 is already addressed by this controller, so that deviation here is now because of delta PL only. That's the meaning. Consider a load change delta PL1 in only area 1. This arrow is not there for us. This arrow is addressed. This load is addressed already. Or you can say this is delta PL2 is 0 here. Therefore, we write the equation at this summer block is delta PM2 plus delta P12. What is coming from area 1 to 2? Together suffice the load here. This was already addressed, I said. Therefore, delta PM2 plus delta P12 equal to the common frequency deviation delta omega into D2, sensitive loads of area 2. So these two are the balance equations at area 1, area 2 point of view. Then from this we know very clearly what is mechanical supplement of power from this area 1. If I have a droop of governor as 1 by R1, we know that when reference point is not altered, how is that mechanical power input to this generator is going to vary? Is going to vary with respect to its droop nature. That is called delta PM1 is nothing but additional mechanical supplement required for the error delta omega to be addressed is delta PM1 equal to minus delta omega by R1. That is the mechanical need over here. If this need is fulfilled, this shift in load is addressed, delta omega become our under control. That's how delta PM1 is the mechanical input, delta P12 is the exchanging power, delta PL1 is the shift in load noticed. Therefore, this has to be from the governor's perspective. That is how that is going to be a value delta omega by R1 negative. Similarly, from the second generator perspective, how is that this deviation, whether it is a delta omega here or delta omega here, that is a common frequency deviation sensed by area 1, area 2. How that delta omega is going to affect the generator area 1 by this way. This delta omega 1 or delta omega will make the set points or governor to operate such that the supplement delta PM1 is worked out here. Similarly, how is this area 2? Area 2 will also have a same impact. Delta PM2 become now minus delta omega by R2. Because R2 is its droop. This will also reflect because omega is common to area 1, area 2. When they are interconnected, delta omega is delta omega 1 equal to delta omega 2. Hence, it becomes a reflection from this area unknowingly. Therefore, area 2 is also going to reflect for the change in frequency as delta omega divided by R2. See here, load changes in area 1. Area 1 has to respond actually, but frequency of this particular interconnected area or deviation of these two areas is common to controller of this, common to controller of this. Therefore, this deviation delta omega is the reason that governor will act and it will make a mechanical supplement here. Similarly, this frequency deviation is common to area 2's governors also. This is also going to reflect delta PM2. See the beauty of this. Area 1 is far away, kilometers or hundreds of kilometers far away, and this is also far away from that. Change of this is addressed by this. Change of this addressed by this other way also when I look other way. Therefore, delta PM2 is minus delta omega by R2. Now I will consider the first equation. Delta PM1 minus delta P12 minus shift in load in area 1 equal to delta omega D1. This is from area 1's perspective. In this delta PM1, I substitute by this equation. What is delta PM1? Minus delta omega by R1. Reflection of area 1 controller for a change in frequency. That is delta PM1. This term I want to replace by this term. You can see here. When I replace this in this position, minus delta omega by R1 from this position, I take to the right hand side. It becomes plus this side. So delta omega by R1 at the RHS side, delta omega is common. When I take delta omega common, what remains is 1 by R1 plus D1. You can see here. So minus delta P12 minus delta PL1 is equal to this term. When I rotate other side, the minus term become plus over. That's how it's going to become delta omega outside 1 by R1 plus D1 into this expression. This is from the first area perspective. Similarly, from this second area also I can do. What is the second area? Delta PM2, delta P12, delta omega 2. If I view this in a very systematic manner, you will find a change here. What is this delta omega? Delta omega is the common frequency deviation. Whether load is increasing in area 1 or area 2, both the areas are suffering for the drop of frequency delta omega here. That is how when the load in one area is caused, others also get affected when there is interconnected operation. Then switch gears must be so sensitive to address this issue. Let us go ahead. When I solve this equation with the substitution of delta PM1, I will be able to get delta P12 power to be delivered from 1 to 2, and the load change occurred in area 1 is equal to change in frequency into 1 by R1 plus D1. If I rewrite this using all these, let's see what is going to happen. Okay. So delta omega 1 equal to, let us see, before going to that, let us rewrite this. What is this? From the second equation, delta P12. What is the power received from area 1 or power sent? I can use this also. So power sent to area 2 delta P12 equal to delta omega D2, and this term delta PM2 from this block, if I get it, this become minus delta omega by R2. If I transfer other side, what will become? Delta omega D2 plus delta omega by R2. If I simplify this, delta omega is common, delta omega outside 1 by R2 plus D2. This is equal to delta P12. Delta P12 from this equation on substitution of delta PM2, response from area 2 as and when there is a change in frequency is delta PM2. If I substitute in this equation, like a first equation, get restructured. Let's see. Delta P12 is delta omega in the bracket 1 by R2 plus. If I rewrite this, delta omega equal to what? Delta omega equal to, because I want to know what is that delta omega 2 or what is that the net exchange of power. For this, I need an expression. Delta omega or exchanged power, I want to compute numerically. To compute this, it becomes necessary for me to make an equation in the form of what is delta P12, what is delta omega. From these two equations, I can rewrite what is delta omega. So for this delta omega, what I will do, first I will work delta omega, later I will work delta P1, which you can see here. Delta omega is worked from this equation. Can you see here? What is delta omega from this equation? Minus delta P12 minus delta P1 L1 equal to delta omega inside the bracket 1 by R1 plus D1. So in this, this delta P12, delta P12. Are you able to see my hovering cursor here? If I take other side, what it happens? Delta P12 become plus this side. What is delta P12? Delta P12 for you is in this page. Delta omega inside bracket 1 by R2 plus D2. So delta omega 1 by R2 plus D2, I will add here. This term when I rotate other side, what is going to get here? Delta omega inside a bracket 1 by R1 plus D1 plus delta omega inside a bracket 1 by R2 plus D2. Hope I am able to make you clear. All this equation get converted as minus delta PL1 equal to delta omega inside a bracket 1 by R1 plus D1 plus delta omega inside a bracket 1 by R2 plus D2. Delta omega is common. Then delta omega, if I take common, 1 by R1 plus 1 by R2 plus D1 plus D2 become RHS side content. So 1 by R1 plus 1 by R2 plus D1 plus D2 into delta omega equal to minus delta PL1. Then what is delta omega? That is written here. Delta omega is directly minus delta PL1 divided by 1 by R1 plus 1 by R2 plus D1 plus D2. See, so interestingly we got the frequency deviation experienced when two areas are operating on an interconnected fashion. Suddenly a load of 1 pu, suddenly a load of 200 megawatt is changed. That change in megawatt divided by group nature, if I account here, I'll be able to get this operation. So recall back, several problems we have solved. In a single area only we have solved. 1 by R1, 1 by R2 like that, D1. So many things we have solved. So now you will be getting, when you have two areas interconnected, for a change in load, 1 by R1, 1 by R2 refers equivalent groups of area 1, 1 by R equivalent 1, 1 by R equivalent 2, plus D1 of area 1, D2 of area 2. This is the new thing you are getting. This 1 by R equivalent like 1 by R2 in the denominator, plus D2 is extra thing you are observing from single area operation and a two area operation. This term 1 by R2 to the regulation and D2 to the D1 getting added, and numerator remain a change. Change is whether area 1, area 2. This is the ratio change in load to the sum of group equivalents plus sum of sensitivity of the load for the frequency. That is the nature change in frequency experienced by interconnected operation of a system. This is delta omega. Now this delta omega I place in this equation. See, it's going reverse. This delta omega I substitute in this position. What I will get? What is that megawatt flowing really? I want to know how much power is flowing from 1 to 2. If I want to get this, delta omega from this equation I place here and into 1 by R2 plus D2. You can see here. Delta P12 equal to delta omega into 1 by R2 plus D2 equal to this delta omega I clipped from this. I clipped from this and placed here. You can definitely see this is going to become minus delta PL1 into 1 by R2 plus D2 divided by, as usual, 1 by R1 plus 1 by R2 plus D1 D2. See, small quantity of work is getting added to your understanding. When we had single area, we had such frequency deviation, we had such representation. This is an extra term you learned today. What is that power flowing between 1 and 2 in terms? Who is going to respond? How it's going to be a change in megawatt individual compensation? We have to understand. For that, you got to know what is that change in frequency experienced, delta omega by both the operating corporations. Then what is that megawatt actually flowing in terms of their regulation and change in values. This is how one can do it. Then we know 1 by R1 plus D2 or D1, 1 by R2 plus D2. These are called as beta 1, beta 2. Composite frequency responses in area. I can write this 1 by R2 plus D2 as beta 2, 1 by R1 plus D1 as beta 1, 1 by R2 plus D2 as beta 2. I can spell this as minus delta PL1 into beta 2 divided by beta 1, beta 2. For a simplicity of understanding, beta 1, beta 2 are the composite frequency response characteristics of area 1 and area 2, which is collectively a representation of 1 by R2 plus D2 as beta 2, 1 by R1 plus D1 as beta 1. So some book refer, this I refer from Dr. K. Umar Rao. If I refer K. Nagat Kotari, probably they'll be referring beta 1, beta 2 like that. So that doesn't mean a change. It is the same, just a substitution. So I speak as minus delta PL1 into beta 2 divided by beta 1 plus beta 2 is nothing but net power exchange. Then what is that? You can write in this way, delta omega into beta 2. What is this? 1 by R2 plus D2? Beta 2. I can write here. This term is simply written as, entire term is delta, mean delta omega into beta 2. Delta omega into beta 2 is the power flow occurring from 1 to 2. That's what I can tell. So therefore, this is how a single area connected to a next area becoming an interconnected area operation. When a load change in one of the area is noticed, how is that deviation in the frequency is observed can be studied. Similarly, when I have a same approach revisited, if area 1 is experiencing a change in load, this was observation. If I speak similar study, if there is a change in load in area 2 alone, not in area 1, area 1 I keep static, area